In continuation to our previous talk on genome mapping, here we are continuing with restriction mapping. Restriction mapping is the first under the classification of physical mapping. In restriction mapping, you have fragments of the genome that are normally digested with EcoR1 sites or BAMH1 sites or restriction enzymes in general to identify the sites on the fragment. So what are you ideally doing? Restriction mapping is nothing but identification of fragments, identification of RE sites on the fragments, identification of RE sites, restriction enzyme sites on the fragments. That is what is RE sites. Yeah. So now what we do is we get into the detail of restriction enzyme mapping, right? So let's get into the detail of restriction enzyme mapping. We take a fragment of 4.9 kb here and digest it with EcoR1 first individually, and then BAMH1 in an individual tube independent of the previous reaction, and then take both of them together and digest together in a separate tube. So there'll be three different reactions in three different tubes. First for individual enzymes, EcoR1 and BAMH1, and then the combination of both the enzymes with the same DNA, right? And you'll be having the fragments that are generated. So this is the primary thing that we do. Here I'm taking a simple example of two enzymes. You can take as many enzymes as you can. But here I'm taking two enzymes for understanding the concept clearly. Now, what do we do here? Let's check. Looking at the fragments of all the three separately, we come to a conclusion of where the sites are. That is our ultimate aim. So what we generally do is, first we'll have a look at the sites in the double digest, And then with the fragments that are present in the double digest, we try to correlate with the rest of the fragments that are there in the individual digests. So first what we do, we take the smallest fragments first and then slowly go to the next bigger fragment and finally to the bigger fragments. So here we consider 0.2 and 0.5 kb together, and 0.2 and 0.5 kb, we first have a look at whether the sum of this 0.2 and 0.5 is present. This is 0.2 kb first and a 0.5 kb first. We'll check whether do we have the sum of these two fragments present in either of the individual digests of BAMH1 and EcoR1. Now let us see. Yes, it is present in the individual digest of 0.7 kb. So what does this indicate? It means that within the 4.9 kb, there is a region that is flanked by, I'll write BAMH1 with B and EcoR1 with E. So there is a region that is flanked by the BAMH1 sites. And what is this size of this region? It is 0.7. Now, what happened to this 0.7? When it is individually digested with BAMH1, you got a 0.7 fragment, indicating that it is flanked by BAMH1. Now, when you have used EcoR1, what have you got? You have got a fragment, let us say, 0.5 kb here and a 0.2 kb here, indicating that within this fragment of 0.7, there is a site for EcoR1. That is decided just by looking at the fragment sizes, because you have these fragment sizes. So it's very clear now. We'll just draw the same map here, that you have a 0.7 kb fragment with EcoR1 site here and with a BAMH1 site here and with a BAMH1 site here. And the size of this fragment here is 0.5 and 0.2 kb. Till here probably it's clear. Yeah. We'll next go to the next fragment, 1 kb, and we'll follow the same format. 1 kb format, 1 kb fragment, it's present in the double digest. Then we'll have a look at, like, if at all we have any subfragments that would correspond to the length of 1 kb. We have 1.22 and 1 kb here. There are no subfragments, but exactly it shows that there is a 1 kb fragment that is exactly present in the single digest of 1 kb. Again, this indicates that we do have a 1 kb fragment that is again flanked by BAM-H1. That's again flanked by BAM-H1. So what do we do now? We attach this 1 kb fragment that we have got now with this 0.7 kb fragment that we have analyzed in our first set of fragments, right? So we have BAM-H1 sites here and with an internal site of eco R1. So what does this indicate? This indicates that this is 1 kb here, from here to here, and this is 0.5 kb and this is 0.2 kb in size. Now, if you are looking at this size from here to here, it means that it is around 1.5 kb in length. And now look at that. Ideally, what happens if at all you have started with this? Look at this. This 1.5 kb fragment is present in the eco R1 digest. So what does it indicate? Yes, probably this is the end of this fragment. This is the end of this fragment. And if this is digested with eco R1 alone, you're going to get a fragment of 1.5 kb. So now we have even identified the end of the fragment. So the end of the fragment is identified as, yes, if this is the end of the fragment here, this is the end of the fragment. I'll write it as END, end of the fragment here. And when you digest it with BAM-H1 alone, right? I'm just drawing the BAM-H1 sites alone. So what ideally you get, if this is BAM-H1, you should get a 1 kb fragment. Yes, right? And here, if you are digesting with BAM-H1, you should get a 0.7 kb fragment. That is what is the fundamental. That's what we have done till now. Right. Now, you have both the sizes of these fragments available in the individual digest here. You have the 1 kb as well as you have the 1 kb as well as the 1 kb as well as the 0.7 kb here, right? And now this 1.5 is an indication of what? If you have an eco R1 site here, and if that is the end of the chromosome, this fragment size which you have got here, this fragment size which you have got here should correspond to one of the fragments that is present in the individual digest of eco R1. And we have already checked that we have got this. So now the map that we are slowly progressing towards is like, this is the end of the chromosome. This is the end of the chromosome. Now this is digested. This is digested with BAM-H1 here. And then you have an eco R1 here. And then you have a BAM-H1 here. So what have we identified by using the second set of fragments? We have identified the end of the fragment. And we have also identified that this is the probable sequence of the restriction enzymes on the fragment of 4.9 kb. Still, we are left to analyze the other bigger sizes of fragments. So what are the bigger sizes of fragments that are there now for us to analyze? It is 1.2 kb and 2 kb. So we'll take 1.2 kb and 2 kb now together. And this 1.2 and 2 kb together. Now check whether you have the subfragments of 1.2 and 2 kb summing up to their lengths in either of the individual digests. There are no fragments that would sum up to the individual, sum up to 1.2 and 2 kb in the individual digests. Right. So now what do we do? But we have what? We have the direct complete length of 1.2 and 2 kb in your BAM-H1 digest. So what does that mean? So that means, like, here, this set is completely clear, right? This end is completely clear. Now, probably we have something like this, that at the end of this BAM-H1 site, we can add these two fragments of, let us say, 1.2 kb and 2 kb here, 2 kb here, 2 kb here, to see that, okay, if at all we digest the entire 4.9, just because the BAM-H1 site is present here, this is a BAM-H1 site and this is a BAM-H1 site. Now you can have a 1.2 kb here and a 2 kb here, and everything falls in place as far as the rest of the fragments are concerned. So with that basic idea, you may ask me, sir, why are you placing 1.2 kb here? You can as well have, instead of 1.2, you can as well have a 2 kb here, and you can have a 1.2 kb here, because when you digest with BAM-H1 anyways, this is getting digested, you get 1.2 kb, this is getting digested, you get a 2 kb. So now we have two sets of possible maps. What are the two sets of possible maps? See, this is confirmed earlier, right? Till here, it's pakka that we have confirmed that this is the probable restriction map. Now, we have two choices here. You can either have 1.2, right, with the BAM-H1 site here and the 2 kb here, or you can have the 2 kb first and then the 1.2. So now you are sure that there is a BAM-H1 site. Whether this BAM-H1 site would lead to 2 kb or 1.2 kb, there's again a BAM-H1 site here, but whether it is a distance of 2 kb or 1.2 from this BAM-H1 site, it has to be decided. So now what do? We take the partial digests. Now why we go for partial digests is mainly because we anyways know that BAM-H1 is cutting at all those sites at the ends, but we want to know if at all it is cutting in the middle somewhere, if it's at all it's cutting in the middle somewhere, on partial digestion, that site which is present in the middle would not be cutting to its completion and would lead to a combined fragment. Once again, I'm repeating. Why are we doing partial digestion? We are doing partial digestion to look at, for example, if there is a site like this here, right? This site ideally should give you two fragments, this and this. Now, under partial digestion, it may so happen that you may not get these fragments completely, right? You may have these fragments, but at times you may have this complete fragment as well without digestion. Is that okay? So now how do you achieve this partial digestion or partial fragments? How do you get this partial digestion? This partial digestion is, for example, the restriction enzyme is ideally given, right, to digest a particular fragment in, let us say, 6 hours. So now how do you do this partial digestion? You do the partial digestion by using the same conditions of restriction enzyme, but you'll be doing it only for 3.5 hours or 3 hours, right? So by doing it for 3 hours, sometimes what happens, it does cut few of the fragments completely, but some of the fragments are left without cutting. So you'll definitely get these flanking fragments which are cut completely to an extent, and as well get a partial fragment that is here, which is not cut with this particular enzyme, because you have not given the complete conditions for the enzyme to cut. So now look at this. Look at this. What are we doing? So here, what are we interested in? We are interested in whether this BAM-H1 site, which is internal, what did I tell you? We do partial digestion only to look at whether the internal sites are completely cutting or not. Now, whether this internal site, if this is partially cut, what do you look at? You look at a fragment. Anyways, you get 0.7 and 1.2 if it's completely cut. If it's partially cut, you get a fragment of 1.9. That is what you have looked at, right? And similarly, if this is partially cut, what do you get? You get a fragment of 2 and 2.7, because we are only looking at the internal site, right? So now you digest it, and after digestion, let us say we got a 2.7 fragment and we did not get a 1.9 fragment. Now this confirms that our map 2 is correct instead of map 1. Because what's there in your map 2? In map 2, let us draw the map 2 completely. In map 2, this is the end of the chromosome. Let us say you had a BAM-H1 site, right? Because this is the end, what do you get? You had a BAM-H1 site which yields you around 1 kb fragment. And then you had an ECO R1 site which yields you a 0.5 kb site. And then again you had a BAM-H1, right? Which yielded you how much? This again yielded you 0.2 kb. And then what you were confused with is whether I have a 2 kb fragment site here or a 1.2 next. It is now confirmed that you have a 2 kb site here, because on partial digestion, what happened? This BAM-H1 did not cut partially, right? And you partially digested only with BAM-H1. And so there's no possibility of ECO R1. So these two together yielded a product of around 2.7 kb. And that is clearly visible in this particular fragment that is highlighted in green. So now this shows that your map 2 is correct. So finally, we say that yes, this map 2 restriction mapping is the correct restriction mapping for our digestion. Now, having got this restriction mapping clear now we'll look at what are the limitations of this restriction mapping. Now, what are the limitations, guys? The limitations are, the first one, it all depends on the number of restriction enzymes that you are considering. The more the number of restriction enzymes that you are considering, more confusing the entire analysis becomes. However, it is proven. First one is, it gets confusing with the number of enzymes. However, it is proven that this holds good only to a fragment size of 50 kb. This holds good only to a fragment size of 50 kb. Beyond this fragment size, as the restrictions enzymes increase and as well the fragment size increases, the number of fragments and the restriction enzymes you will be getting after digestion will be too many for us to analyze, and this gets very difficult for us to analyze. So what is the ideal fragment size for restriction mapping? The ideal fragment size for restriction mapping is only 50 kb. Right, guys. In the next class, what we do is we'll talk about optical mapping. Thank you.